Okay, you guys, got a little head start on this one. You can see I've already started it kind of, but then I left something out, so I'm redoing the video. But anyways, so, ka, toa, that's your basic starting position. That means sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. But we also have to know that cosecant is hypotenuse over opposite. It's the reciprocal of sine. We know that secant is the reciprocal of cosine, so it's hypotenuse over adjacent. And we know that cotangent is the flip of tangent, so it's going to be adjacent over opposite. So we got to be looking out for all 6 of those in this little exercise. So this is saying, drawing your attention to angle A, and if that's our focus, this is our opposite, this is our hypotenuse. By process of elimination, this is our adjacent side. So this one should be somewhat easy. We know that sine is opposite over hypotenuse. So the opposite is 16, and the hypotenuse is 34, but that can be reduced to 8/17. Now they throw a little zinger at you. 17 over 15, you don't see 17 over 15 anywhere, so that might throw you, but if you notice, we double each side. That'd be 34, and that'd be 30. So this is my hypotenuse, and this is my adjacent. So we look for where does that happen in regards to angle A. Well, hypotenuse over adjacent would be secant. And that's how you attack that. Now this one's kind of the same, 8/15. So if I double those, that'd be 16 over 30. So that means I have the situation where I have the opposite. I'll write that down, opposite, because that's what the 16 is, over the adjacent. We go on a hunt. That's tangent, opposite over adjacent. So I'd slide a little tangent in there. Cosine. Cosine is adjacent over hypotenuse. So our adjacent's 30. Our hypotenuse is 34. And we just reduce that. The other thing we could do is just reduce these right away and say this is 15, say this is 8, and say this is 17, and kind of work at it like that. So cotangent of angle A, cotangent is adjacent, which is 15, over our opposite, which is 8. Now we could have went 30 over 16, but that's just going to reduce to 15/8 anyways. So now they're saying, all right, what trig function of angle A is 17 over 8? Well, that'd be hypotenuse over my opposite. Where do we find that? Cosecant, hypotenuse over opposite. So that's messing with you a little bit. Now they're going to attack a little different. Knowing that cosine is 12 over 37, so I know we have a right angle. It's the only way we can use trig. So they're saying this is the adjacent side, this is the hypotenuse. So we can label that 37. And if I just randomly put that somewhere, not that my drawing's perfect, but my adjacent side would not be my opposite. This is my opposite, and my adjacent would be 12. So there's my generic drawing. It says what are the other 5 trigonometric ratios? Well, I got to use Pythagorean theorem here, so I'm going to call that x. So a squared plus b squared equals c squared. So I know that's x squared plus 144 equals, don't have this one memorized, so 37 squared is 1,369. So they're giving us some crazy numbers. Subtract 144, subtract 144. So I get x squared is, so I got to subtract 144, I get 1225. Now I take the square root of both sides. I know I only have to consider the positive because that's a length. So I'm going to just take a stab and Look at that. Gives us a nice, neat 35. So that works out awfully nice. But that's a tough little Pythagorean theorem. So we got cosine. So sine, and then I'm going to find cosecant, because I'm just going to flip it. Cosine, I already know, because they gave it to us. It's 12 over 37. Secant, we can find that right now, 37 over 12. Just flip it. Still got to find tangent and cotangent. Well, sine is opposite, 35, all over hypotenuse, 37. Flip it to find cosecant. Tangent would be opposite, 35, all over adjacent, 12. So this is my hypotenuse, this is my adjacent, if you were wondering. And now I can just flip that. 12 over 35 gives me my cotangent. So there's that one. All right, so I'm going to get this drawing drawn and then explain it. All right, so just to get this started, a flagpole is 24 feet tall. There it is. We know there's the ground here, just ground. A support wire, that's this, runs from the top of the flagpole from here to the ground and anchor on the ground. It makes a 73-degree angle. Now I tried a line out here, but then I noticed this would look a lot less than 73, so I want my drawing to be a little bit accurate looking, 73. With the ground, this automatically makes this the opposite side of that 73-degree angle. We know this is 90. How far is the anchor from the base of the flagpole? So the anchor's right here and the flagpole's right here, so they're saying find x. Well, we know this is the hypotenuse, and that's not what we're interested in. So that's my adjacent side. And we go back up here, tangent uses opposite over adjacent. So we're going to focus on that angle, and we're going to go tangent of 73 degrees. That's our reference angle, is opposite over adjacent. Now I get out my calculator, and I need to find out what tangent is. Now I will say this, go to your mode. Let me clear this out. Let me go to mode. We want to be in degrees. Notice this thing's in radians. Pre-calculus class, you'll learn about what radians are, but we're dealing with degrees. So we got to go down to our calculator, make sure to highlight degrees, clear it, and now our calculator is accurate. So tangent of 73 degrees is 3.27 equals 24 over x. Now don't forget, we're trying to find x. So we're going to multiply by x to get rid of it over here, but then we got to multiply that side by x. So we're just shifting the x to the other side essentially. And now we can just divide by 3.27. 3.27. Let me grab my calculator. And there we have it, 7.34. I don't want to bore you to absolute stitches. I'm not going to finish this, but if that's 73 and that's 90, I know that this has to be 17 degrees. So I could have used that one, and I could have went tangent of 17 degrees is opposite. So now this is the opposite, making this the adjacent, and my math is going to be a little bit easier, because now I would just take my calculator, find out what tangent of 17 degrees is, 0.3057 equals x over 24. Now I just have to multiply by 24, cancel, multiply that by 24, and notice I get the same darn thing. So different ways to solve these. Here we go. Find a positive and a negative coterminal angle. So we got to figure out where this goes. 280, that's a positive spin. I know that's 90 plus 90 plus 90, which is 270. So I have to go 10 more degrees. That might be more than 10, but I'm just going to squeeze that in there just because it's going to help us understand what's going on. In this situation, the negative one I think is the easiest, because that would be negative 80 to get to that same spinner. But to get another positive, so here's my negative one, to to get another positive, I'd go all the way 280 and I'd go around again. So it's really just adding 360, which is another revolution, and that'd be 640 degrees. So if I spin it 280, it ends here. If I spin it negative 80, it ends same spot. If I go 640, I go around 280, and I end up in the same spot. Now notice this one starts with a negative. So I go 270 plus 60, which would drop us right about there. So remember I said 270 and 60, leaving us with 30. And those little details matter because the positive spin is just spinning it up 30 to end at the same spot. So that's pretty easy. Now the negative, because my initial problem was negative, I'm just going to add another negative 360. In other words, I go around 330, and then from here I go around another full circle, which is 360. So I add these together and I get negative 690. Those aren't too bad. Okay, so this one says find the missing sides of the special right triangle. That means we've got some rules that we should have memorized. Then find the trig ratios. Well, notice we got a 60 here and 90 here. That means this is 30. And if you recall, we multiply that by 2 to figure out what the hypotenuse is. So that's 16. And we multiply that by the square root of 3 to get the side opposite to 60. And now we've got our sides. So what's cosine of 60? That's saying this is our reference angle, making this my opposite. This is my hypotenuse just because it is, and this must be my adjacent. Remember, cosine is adjacent over hypotenuse. So my adjacent side is 8, my hypotenuse is 16, and that reduces to 1/2. Tangent is TOA. So my opposite side of my 60-degree angle is 8 square root of 3. My adjacent side is 8, so that reduces to the square root of 3. 45, 45, 90. So if that's 90 and that's 45, this has to be 45. So if that's 10, this has to be 10. And the rule is we multiply that by the square root of 2 to get that hypotenuse. So what's sine of 45? Notice that's 45 and that's 45. I'm just going to pick this one because it's going to be the same. Opposite, adjacent, hypotenuse. So sine would be opposite 10 over my hypotenuse, 10 square root of 2. Now the 10's cancel, so I end up with 1 over the square root of 2. Get that square root of 2 out of the denominator, and looky there. What's tangent? Well, tangent is opposite over adjacent. Well, notice opposite is 10, adjacent's 10. 10 divided by 10 is 1. Almost done. The angles given are in standard position. All that means, that's fancy talk for start here always, and you should know that by now. What's the reference angle? Well, spin it 65, that means up, and then stop. Well, the reference angle's always sandwiched between the spinner and the x-axis. So it's not very often this happens, but our math problem is our answer. This one will be a little different. Standard position just is a hint to start there, because you always start there. 90 plus 55 adds up to 145. So I'm going to stop right there. My drawing's not perfect. My reference angle is not this. It has to be sandwiched between the spinner and the x-axis. And that would leave us with 35. That's my reference angle by definition. Here we go. Convert each radian measure to degrees. Well, these are the easy ones. You might have this memorized. Pi over 3 is just 60. If you don't have it memorized, remember pi is 180. You can always substitute 180 in for pi when you're dealing with radians. Divided by 3 is 60. Now, this is a degree measure, so if we remember, we got to convert this to radians. Now, if you have it memorized, it's pretty easy. It's just negative pi over 6. Now, how could I get there if I don't have it memorized? Well, remember, there's a formula, negative 30 over 1, that's what this is, degrees, I'm going to write that, and we can multiply that by pi radians over 180 degrees. Now this is like chemistry class, the units cancel, and that's good because we don't want degrees, we want to be left with radians. We know our answer is going to be negative. 30 goes into 30 once, goes into 186 times. So that's negative 1 pi all over 6. So there you go. Another way you could think of it is, well, I think I'll just leave it right there. Here we go, number 8. Find the measure of a positive and a negative angle measure for the angle that has a terminal side in quadrant 2. That means the spinner starts here always. It has a reference angle of 60, so it spins up into quadrant 2. Remember, this is quadrant 1, 2, 3, 4. Quadrant 2 has a reference angle of 60, so I'm going to stop there. I know this is 60, leaving this with 30, and that means this is 90. So how far did we spin our spinner to have it stop right here? 90 plus 30. So the positive one is 120 degrees. The negative one would be here to here. So that's 90 plus 90, which is 180, plus this little sliver of 60, so that'd be negative 240. And that finishes your quiz review.